Hello students, in this video we are going to learn about EOT question number 10, and this question is actually famous for the human cannonball. Okay, all the students what I know from the grade 11 advanced, they are specifically searching for this question. So after finishing this video, this question seems like a very easy, just piece of a cake for you. Okay, now the basic things: solve problem related to work and energy for the spring force. Okay, few things which you should know. Okay, whenever you have a simple word called work which is equals to energy, there are the two energies: kinetic energy, which is half mv square, and the potential energy, which is your mgh. Okay, second thing, in case of spring we have the work done. Before that, in case of spring, just write down like this: spring, you should know two things. One should be force, which is equals to negative kx, and the work done, which is equals to half kx. Clear? So I'm going to use all these things to solve the numerical. What is the concept of human cannonball? Okay, as per the human cannonball, let's say we are using a spring. This is your case number A. We are using a spring, and a person who is standing on the spring, once we release the spring up, it will go up, and it will touch a particular height or a certain height. Okay, so we need to focus on all these parts. Now, the major point: whenever you are solving any numerical, when there is a height of the human being is involved, just always check the foot, the legs, this part. Every time you need to focus on this part. Every time your height is this one. Clear? This is the key part for you. Okay guys, now let's read the question. Assume the barrel is 4 meter long. Okay, the height is 4 meter long. Okay, this height is 4 meter. Okay, with a spring that extend the entire length of the barrel. Okay, I'll just write length, or barrel length is 4 meter long. Okay, extend the wire of the length further. The barrel is upright. Okay, it will move upright, so it points vertically towards the ceiling. Okay, we know towards the ceiling of the circus tent. The human cannonball is lowered into the barrel and compress the spring to some degree. Okay, once the human is here, okay, case A is normal, there is nothing, no force is involved. Case B, you need to think there is a human being who is standing on the spring. You need to understand how many forces are going down. Two forces. How many forces? Two. One is because of the human, and one, the spring is going down. So we need to understand all these things. You can say F1 and F2, and there is a spring, so F1 plus F2 should be equals to, in case of spring is minus kx. Okay, just you need to remember. So in this, one force should be mg, so you can say mg plus additional force, which is equals to negative kx. Okay, B part is clear. Okay, now the human cannonball is lowered into the barrel and compress the spring to some degree. The external force, you understand, this is the external force or the added force, is added to compress the spring even further to a length of only 0.70 meter. Okay, so we are compressing it, and the height is 0.70 meter. Okay, there is a difference, this one 0.7 meter. Okay, at the height of 7.5 meter above the top. Okay, this is the total height is 7.5 meter above the top of the barrel is a spot on the tent that the human cannonball of height 1.5 meter. Okay, human height, you need to understand. This is your human, his height is 1.7 meter. Okay, and remember we need to check his foot, not the head. This is head, this is foot. Okay, always focus on this part. Okay, mass is given 68.4, is supposed to touch the top of the trajectory. Removing the external forces released the spring and fires the human cannonball vertically upward. Okay, few things are given, we need to understand. And the major thing what you need to focus, that the total energy, what is the total energy? Kinetic energy plus potential energy, always conserved. Always conserved. Okay, now let's move to the question and we will solve one by one. So, total energy remains conserved. So, how many parts? Part A, part B, part C, part D, and part E. Everywhere your energy remains the same. Okay, now what is the value of spring constant needed to accomplish this stunt? Okay, first thing, as I told you, energy at A equals energy at B equals to C equals to D and equals to E. Clear? Okay, now just check the question. A, no need to use that, this is the normal case. B, yes, this is something very good. Okay, we are going to find total energy at B. Can I say kinetic energy plus potential energy? Yes or no? Fine. Okay, which kinetic energy is here? Spring kinetic energy. Which energy? Spring kinetic energy. So the formula is half K. Okay, what is the distance he is covering? It is okay, you need to understand it is going down. He is going down. Let's say give him the name YB because it's under Y axis. Sure? Okay, so YB square. Clear? Plus mgh. We know potential energy is your mgh. Height is your mg. What is the height here? yb. yb. Clear? You understand? So this is the total energy at position B. Fine? Okay, write down here. So energy at position B is half k yb square plus mgyb. Okay, now at position C, okay, this is your position C, and if you see, this is the 0 position, so height should be 0. Okay, energy at C, kinetic energy plus potential energy, and here height is 0, so can I say only kinetic energy? Sure. And which should be equals to half mv square. Half mv square. And you can write C. This is the position C. So energy at C is equals to half mvc square. Okay. Okay, now D position is in the air. No need to solve because that is in the middle. Okay, E point. If you solve energy at E point, then what will you observe at E point? This is the maximum height. Maximum. Yes or no? So at maximum position, velocity should be equals to 0. And height should be maximum. And we need to use the human foot. Yes or no? Okay, now what you need to understand, the height is, if you observe, what is the height? Total height from 0, it is given 7.5, and human is here. So where is the legs? Here. So what is the effective height? Can I say 7.5 minus, what is the height of human? 1.75. This is the height of human, 1.75. So this is your effective height. Clear? Understand? Okay, so what should be the answer here? Kinetic energy, that should be 0 plus potential energy. So what should be the potential energy? mgye. Clear? Equation number 1, equation number 2, equation number 3. Now what we need to solve? We need to solve the k, value of k. Take equation 1 and equation 3. From equation 1 and 3, what we get? Half k times of yb square plus mgyb equals to mgye. Can we place all the values? We need to find the k. Okay, so take this value this side. So half kyb square equals mgye minus mgyb. Clear? Okay, so k is equals to mg common ye minus yb. Okay, multiply with 2 and divide with yb square. Fine. Can I place all the values? Okay. Now just check what are their values. So what is ye? I told you what is ye. So ye is 7.5 minus 1.5. Fine. What is your yb? It is going down. Down means negative. You can just check here. We are compressing. We are going down. Do you understand? So how much? From 0 to negative 3.3. So what should be the value? Negative 3.3. Clear? Okay. Put your values here. Okay. This is the 1.75. 1.75. Okay. Now place everything here. K is equals to 2. What is the mass of the body? 68.4 multiply 9.81. Okay, now bracket. So 7.5 minus 1.75 bracket minus 3.3 bracket close divide by negative 3.3 negative 3.3 whole square. Solve this value, guys. Put in your calculator fast. So you will get 1115.26 Newton per meter. Clear? Fine. Okay. Like this you need to focus, huh? Okay. Now we have the next part, and that is the easy one. What is the speed? Okay, for the speed, what we need to find, take equation number, just take any two equations. Let's say 2 and 3. Take 2 and 3. So equation from equation 2 and 3. So can I say half mvc square should be equals to mgye? Yes or no? Sure. Okay, solve it. Take 2 this side. Okay, first of all, mass and masses cancel. So vc square equals to 2gye. So vc is equals to root of 2gye. Place the values. Vc is equals to root of 2 multiply. G is your 9.81. Ye is 7.5 minus 1.75. Yes or no? Okay. Or you can just simply say 5.75 also. So 2 multiply 9.81 multiply 5.75 root. So velocity is equals to, what is the value? Just find out fast. 10.6 meter per second. Clear? Easy? Okay. Now the next part. What is the magnitude of added external force? Do you remember I told you when there is a human being, this is the spring, there are the forces. One force which is mg. One force you are pressurizing this, that should be added force. That is added force. Okay. And the third thing, spring is compressed, so the force should be equals to negative kx. Clear? Sure? Okay. So now solve this. So what should be the answer? F1 plus F added equals to negative kx. Okay. mg plus F added equals negative k. What is the value of x? Negative 3.3. So it should be plus, and what is the value of k? We already solved this. So 1115.26 multiply 3.3, and here mg, m is 68.4 multiply 9.81 plus f added. So f added extra 4 should be equals to this much, 1115.26 multiply 3.3 minus 68.4. Wait. I need to take this aside. Okay. Now 68.4 multiply 9.81. Okay. So solve this and you will get the answer. Okay. Solve it fast. So F added is equals to 3009.4 Newton. This is your additional force. Clear? Mg always act downward. Always acts downward. And this F additional you need to focus. Okay? Now, next part. What is the maximum acceleration? Okay, we are looking for acceleration. As we know, F is equals to ma. Okay, that the human cannonball of solved problem. Okay, so we know F equal to ma. A is equals to F divided by m, and we know we have what is the added force. Okay, so solve this. 3009.4 divided by what is the mass? 68.4. 68.4. So what is the value? 44 meter per second square. Clear, guys? Now you understand? Sure. Okay, this is something very good, huh? Very important one. Okay, next question. As per your EOT, these are the questions they have already given to you. Okay, focus on this one. A block of mass, okay, given. In the given part, mass is 0.773 kg on a spring. I told you, whenever you will find this word spring, you should remember two things. Force is equals to negative kx, and energy or work done half kx square. With a spring constant, okay, k is given 239.5 Newton per meter. Oscillates. Okay, this is the second point you need to focus on. Oscillates means it's like a pendulum. Okay, it will move like this. Okay, so here you need to focus few points. This is the length L, or this is called amplitude, and the motion which is taking, this is your x. Okay, this is your motion. Clear? Okay. Oscillates vertically with the amplitude. See, amplitude is given. A is equals to 0.551 meter. No need to solve. What is the speed? We are looking for velocity of the block at a distance. Distance is x is given 0.331 meter. Clear? Okay. Now what you need to focus? First of all, see, you have the sum of energies here. Sum of energy is total energy from the spring. Total energy from spring equals to kinetic energy plus potential energy. So, in which way you need to understand? Half Ka square. This is the amplitude of the spring. Should be equals to. There are the two energies. One, half mv square plus half kx square. Yes or no? Do you understand? Okay, now solve this and you can find the value of velocity. Okay, cancel the half from all the parts. Half cancel. So you will get ka square equals to mv square plus kx square. Take this value this side. Ka square minus kx square equals to mv square. Okay, now solve them. So you need to find velocity. Velocity is equals to k a square minus x square divided by m. This is the velocity square. So velocity is equals to root of k by m a square minus x square. Clear? Now just place the values. V is equals to, what is the value of k here? Yes, tell me fast. It is given in the question. Okay, 239.5. Okay, I will place it here. 239.5. What is the mass? 0.773 bracket 0.551 square minus 0.331 square bracket. Okay, now just solve this part. Okay, make it here so that it will be clear. So velocity is equals to, what is the value of velocity? Velocity is 7.75 meter per second. Fine, easy. See guys, just whenever the question will come, you need to focus how many things are involved and what he is looking for. He is looking for energy or he is looking for force. Finish. Nothing too much, huh? Okay, here also what you need to focus, that is the major point. Just concentrate how many things are given and how you need to solve this point. Okay, a spring we know the force and we understand the energy also. K is given, K is equals to 10 Newton per centimeter. Okay, no need to change it because it is given like this. Fine. Okay, now what is the value we have? Initially stretched 1 centimeter. Initially stretched, so x1 you can say, or x initial you can say 1 centimeter. Okay, 1 centimeter. From its equilibrium position, okay, how much we need to look for? Part A. Part A. How much more energy? You need to focus on energy. Energy should be equals to half k x square or half k. Now just focus on, in case of energy, whenever we are solving this one, x initial square minus x final square. If you solve the integration, because if I place the negative values, the negative will become positive, is needed to further stretch the spring to 5 centimeter. 5 centimeter. Okay, xi I have 1 centimeter. Can I say 1 multiplied 10 is for negative 2 meter? Okay, xf is equals to 5 centimeter. Can I say 5 multiplied 10 is for negative 2 centimeter? Yes, and I need to solve this one also. 10 Newton. Okay, centimeter to meter. So 10 raised to power negative 2 meter. So can I say 10 raised to power 3 Newton per meter? And you need to focus specifically on the units itself. Okay, now everything I have, what I am looking for, we are looking for the energy. Place the value. So W is equals to half k. K is 10 raised to power 3 bracket. Okay, what I told you, xi minus xf. So what is the initial value? 1. So 1 multiplied 10 raised to power negative 2 square minus, what is xf? 5 multiplied 10 raised to power negative 2 square. Okay, solve this, put all these things in your calculator, and what you will get? You will get 1.2 joule. This is your work done. Even if you get the negative value, you should understand, you will get the negative value. So you need to understand, because he is asking needed. So we need to give the magnitude only. Okay, fine. Next part number B. From this new position where we are now, okay, you need to understand, Now this is your spring and this is your 1, and now you stretch this up to 5. Okay, so now this will become, for case B, this is your initial position. Okay, now from now this new position, how much energy is needed? Okay, again you need to find the energy, case number B. Okay, so work done should be equals to half K xi square minus xf square. Okay, initial I understand, x initial is 5 centimeter, which is equals to 5 multiplied 10 raised to negative 2 meter. Okay, little bit make it more, x final equals, okay, is compressed the spring to compressed. Okay, we are going this side, we are moving this side. Okay, from this position to this position, 5 centimeter shorter. Okay, so here should be negative 5 centimeter. Clear? That is equal to negative 5 multiply 10 raised to negative 2 meter. Fine, place the values. Work done is equals to half K, I already solved 1000. Okay, 5 multiply 10 raised to power 2 square minus bracket minus of 5 multiply 10 raised to power negative 2 square. Okay, so both are same. Let's say this is your A minus B, both are same, and A equal to B. So the work done is equals to 0, because the positions are just exactly equal and same. Clear, guys? Do you understand? Fine. Okay, guys, so in this video, what do you understand? How to solve the question on the basis of spring. And whenever you see the spring, there are the kinetic energy and there is the force. Force is equals to negative kx and energy is half kx square. So on the basis of this one, you need to solve all the questions. Clear, guys? So you understand the basics of cannonball also, you can solve it easily. Okay, guys, so just wait for the next video, which will be updated soon, and keep on sharing the videos with your friends so that everyone can take the benefit of my hard work. Okay, guys, till then, take care. Bye.